These are the solutions to the investigating and comparing data distributions test. Alright, so let's get on to the questions. Question 1. Data is collected on the shopping centre most visited by students. Alright, so to answer these questions, I always imagine doing this. Okay, so we're collecting the data on the shopping centre you prefer to visit. So I'd imagine asking someone and they go, oh, I like Southland. I like Chatty. Etc, etc. And what you can quickly see is the shopping centre that they choose is a category. Okay, it's categorical data, and because there's no order to the data, it's categorical and nominal. So C. Alright, following graph is best described as. So at the top end of the range we have most of the values, so we say that this is a negative skew. Alright, we've got a percentage frequency table here, and we're looking at the preferred sport, and the percentage of students who said that listening to music was their favourite leisure activity. So we go listening to music, and we're after that one there. So it's just 70 over 250. 70 over 250 times 100. Go to your calculator and work that one out. Control Doc and add calculator. So we go 70 over 250 multiplied by 100, and that's 28%. So there it is there. The number of students who said watching TUV was their favourite leisure activity. So we're interested in this one here. It's whatever's left over when you remove the 3 results from 250. So again, let's go back to our calc, and we've got 250 take away 73 plus 70 plus 59. It's 48. Okay, so it's this one here. Alright, got some data here on the average rainfall per month in the city of Darwin, and the first thing we want to do is find the mean. So I typed in the data before, there's rainfall, and there's my 12 data points. So to work it out, we're going to do the one variable statistics. So we go menu 4 1 1, number of lists default is fine, and we're doing it on rainfall. It's not in a frequency table, so everything stays blank. Alright, let's go check it out, and we've got 144.1 as the mean, or X bar. Okay, is what we're after. So that's that one there. The interquartile range, so IQR equals Q3 take Q1. So again, what we'll do is we'll just get that off the one variable statistics, which is 284.9 subtract 10.1, so that's 274.9 to 74.8. So it's going to be D. Do it on the calc if you're not so good with decimals. Choose which statement below is true. There are outliers, there are no all of them about outliers. Okay, so the best thing to do, girls, is to basically run a box plot, or do a box plot of the rainfall data, and a box plot will tell you whether there is any outliers. So let's go Control and Doc. We want data and statistics. We're going to use rainfall and change your plot type to a box plot. No outliers, so it's D. There are no outliers in the data set. Alright, question 8. We've got back-to-back stem and leaf plots showing the distribution of marks. So which of the following marks would be considered an outlier for a student in class A? So we're looking at this data here, this side, and outwardly it looks like 79 and 80 are outliers, but I wouldn't bet on it. So you really need to check. So what we're going to do is add a list and spreadsheet, marks, and we're going to enter the marks. So I'll just pause the video. Okay, so now that the data's been entered, let's check it out. So again, to show up outliers, the easiest way to do a quick check of outliers is to do a box plot. So go to Control and Doc, do another Data and Statistics, this time using Mark as your variable, and we'll go Menu, change the plot type to a box plot. Okay, and let's check it out. It's actually a little bit hard to see, okay, but what we can do is go Menu, Analyze, let's go Actions, no, Plot Properties. How do I do a trace? Okay, so to do a graph trace, what we're going to do is go Analyze and Graph Trace. And then we use this key here, we go across. So the Q1 is 32, Med 36, Q3 51, our max is 79, and we've got one outlier, 80. Okay, so in fact 79 is included in the data set, so it's 80. So the only real way to do this is either box plot or you do the upper fence outlier check, which remember is Q3 plus 1.5 times the IQR. So that's another way. If you can't read it off the graph or you're not sure what the graph is saying, run the upper end or the upper fence outlier check and that will tell you. Okay, the appropriate comparisons for the measures of distribution for the center of the two classes are. So we're looking at the skew for both of them. Okay, and well, let's have a look. Alright, so this is the data here. Okay, so we've got clustering or a lot of values happening at the lower end of the range. So what we say here is this is a pos skew. Over this side here, again, we've got this sort of a lot of values happening at the lower end. So both of them have a pos skew. Okay, so both A and B have this positive skew. So let's see which ones. Class A is negatively skewed, so that's out. Class A is positive, Class B is negative, both positively skewed. Okay, so that's the only one that actually can be correct without even worrying about checking the median. But they're saying the median for Class A is larger than Class B. Let's just make sure. Here's Class A, and it's definitely going to produce a higher median. Alright, the parallel box plots for the distribution of the number of hits on one day on a website. Alright, which of the following statements are true? And the only real way to do this is to just knock off these statements one by one. On more than 75% of days in January, the website had less hits than any day on February. So here's January. Yeah, this is January's data here. And on more than 75% of the days in January, the website had less hits. Well, here's 75% of January's data here, from there to there. And what you can see very quickly is that they racked up 75% of their hits before February's minimum actually occurred. So in fact, we don't need to go any further. This is the correct answer. Alright, so on to application. The following frequency table refers to the number of hot drinks purchased at a school canteen on a Monday morning by the first 20 people who walked through the door. Okay, so how many cappuccinos did the first, cappuccinos and espressos did the first 20 people order? So they ordered, how many cappuccinos? 2 cappuccinos and 7 espressos. Okay, what's the percentage frequency of people who didn't purchase an espresso? So it's not 7. Okay, so it's whatever's left over after that. So 13 out of 20 multiplied by 100. So that would be 65%. What would be the most appropriate graph to display it? Because it's categorical data, bar chart is the way you want to do this one. Okay, so we've got the data referring to the wait time by 25 cars stopped in traffic on Springy and Headlerton Road. Okay, so while I do the data entry, I'll just pause. Okay, the data's in now. And so what we're going to do is complete the frequency table using intervals of 5 starting at 0. So let's set up our intervals: 0 to less than 5, 5 to less than 10, 10 to less than 15, 15 to less than 20, 20 to less than 25, and 25 to less than 30. Okay, the easiest way to do this, a lot of you just processed it by hand, but the easiest way is to get the calculator to generate the histogram for us. So we're going to go Control and Doc, do Data and Statistics, and change our plot type to a histogram. And what we're going to do is just do plot properties, and we're going to change the histogram properties. The one we want is bin settings. Okay, so there's a lot to do this, but we want to get to the bin settings. So I'll show you how to get there again. We're going to go plot properties, histogram properties, bin settings, and equal bin width. Basically what this is, this one here is interested in how wide the intervals are, so that's 5. And the alignment says, hey, basically where do you want to start the histogram? So it's at 0. Okay, in this case, so 0 is the start value with an interval or a gap of 5. So we hit OK. Alright, so now that does the histogram for us. Now what's the point in this? Well, what you can do now is you hover over each one and it tells you between 0 and 5 is one data point. So I can fill in my table. So tally is 1. Okay, this one here is also 1. This one here, and let's fill in the frequency while we're at it. 1, 1. So we've got 3, 5, 8, 7. 3, 5, 8, 7. And 25 and 25. Okay, so then you had to use that data to construct the histogram. It's really important that you mark the scale correctly. So this is the origin here: 0, 5, 10, 15, 20, 25, and 30. And let's go up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc. Alright, so between 0 and 5 was, I think, from memory 1. You need to use a ruler for this, okay, but I'm on a stylus here. It's very difficult to use a ruler on this. That one was also 1. This one was 3 from memory. And then it was, let's just go back to my calc and find out, 5, 8. So this one here was 5. This one here was 8. And the last one was 7. Okay, so this was frequency here, and here this was forgotten actually. It's the wait time in seconds. Okay, the histogram has a lot of values occurring at this upper end of the range. So what we've got here is a negative skew. Alright, what we've got here, ordered back-to-back stem and leaf plot, shows the percentage of babies that were only breastfed during the first 6 months of their life in 22 developed countries and 22 developing countries. Now it's important to note, developed countries means countries like Australia, okay? So these are, highly developed countries, make a lot of money, GDP, etc., etc. Okay, developing countries are generally, poorer countries, countries that are struggling a bit. Okay, so what we can see here, the Q1, the median, and the Q3 have already been added to developed countries. So we're going to do the same thing for developing countries. Alright, so what we've got is 22 in the developing countries list. Okay, so we're going to run n plus 1 on 2 to get the median position, which is 23 on 2, which is 24, 11.5. So it's the 11th and the 12th piece of data that is the median. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These two are the median. So we've got a median of 53. Alright, so if there's two numbers that are the median, there's no direct median, then these two numbers get split, okay? And what that's going to do is basically leave we're going to leave the numbers in this case, okay, and we'll put one number on either side, okay. So that'll leave 11 at the lower end, 11 at the upper end. So 11 plus 1 on 2 is 12 on 2 is 6. The sixth number is the Q1. 1, 2, 3, 4, 5, 6. That's the Q1. 41 and 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. The Q3 is 61. Alright, explain the differences in the centre and spread of the breastfeeding data. Alright, so centre refers to these things here, the median, and spread refers to either IQR or range. Okay, so what you need to do to get full marks for these questions is when you talk about centre, you need to have evidence and you need to have context, okay? So I would say something like the developing countries have a higher median rate of breastfeeding, and quote it. It was 53 compared to developed countries, which was 32.5. Okay, and then because there's no outliers in the data, we can use the range to compare spread. So let's have a look. The spread of developing countries is 82 take 27, so that's 82, 72, 62, 62, 55. So the range is 55, and the range over here is 54 take away 14, which is 40. Okay, so using those numbers, then we'll say something like this: the developed countries had a greater spread so that's the developing countries had a greater spread, which was 55 compared to developing countries, which was what was it, 40. Okay, so needed this context here. So developing countries, developed countries, you needed to mention those words. You need to do a comparison, so one's higher than the other, and you need to support it with evidence. So there's a lot to do with these questions. Alright, the mean and the standard deviation for developing countries. There's only one real way to get that, and that's to actually put the data into a list. So let's do it. Okay, so now we've got the data into list and spreadsheet. We'll go and do the one variable statistics, so stat calculations and the one variable. I called it DV for developing, and hit enter. Check it all out. We've got an X bar or a mean. No suggested rounding here, which is a bit naughty, but whatever you rounded to was acceptable. Let's just do 2 decimal places, 51.72. And the standard deviation, this is the one we're after here, SX, the sample standard deviation. So SX is 14.22. Alright, last question. So, president of a netball club is assessing the performance of his teams in 2016. Each team played 12 games. The president records the number of wins by each of the 18 teams. They have entered in the following table. So basically, spent a second trying to work out what it's saying. The Celtic had one win out of the 12 games that they played. The Rangers won none. Arsenal won one, etc., etc. So the president feels that winning more than 8 games will result in the final appearance. What percentage of teams does he expect to play in the finals? So you've got to find the ones that had more than 8. That's that one and that one. Okay, so 9 wins is more than 8. A lot of you included this one here, the blue streaks. That's 8 wins. That's not more than 8. That is 8. Okay, so that doesn't include. It's not included. So it's 2 out of 18 multiplied by 100. So we're doing this to 1 decimal place. So let's go back to the calculator. Two out of 18 times 100, 1.11 or 11 point rather, 0.1%. Complete the 5-number summary. So there's only one way to do that. Okay, now that the data's in, we can do the 5-number summary. So again, we're going to go menu 411 on the results column. Okay, we've got a min of 0. Q1 is 2.5. Med is, Q1 is 1. Median is 2.5. Q3 is 5. Our max is 10. Okay, so now we're going to do a box plot. Now, we want to be a little bit careful here and consider whether there's going to be an outlier. So you could basically do a box plot on this, but I know there's not going to be any outliers. 0, there's 3 teams on 0, so there's no lower end outlier, okay? And there's definitely going to be no upper end outlier because Wolfpack won 10 games. That's not going to be an outlier because the Blue Devils won 9, the Blue Streaks won 8. So all of those values are pretty close to each other. And so even though 10's high, it's the highest number, these two values, 8 and 9, will pull that in. Okay, so it's definitely not going to have an outlier. So we can go ahead and plot it here. So we've got 0, 1, 2.5, 5, and 10. Okay, so there's the box component, and there's our whiskers. Okay, complete the following statements. In 2015, the top 25% of the teams had more than. So this is the top 25%. This part here had more than this amount of wins here. That's 9. 50% of the teams had less than. So this is 50% here. Okay, and that is 6, 7, 8. Less than 8 wins that season. With reference to measures as centre, compare the performance of the netball club's teams in 2015 and 2016. So what's clear is that their 2015 campaign was much better than their 2016 campaign. So we're going to use medians to compare. Okay, so I would say something like the teams performed worse in 2016, median was 2.5 compared to 2015 median was, let's see, I think it was 8. Yeah, 8. And that's all you needed to do for that. Okay. And that's the test.